All right, today we're going to be verifying trig identities. This is a very similar lesson to the one we worked on yesterday. However, on this one, you know where it is that you're heading. So one of the main questions from yesterday's lesson was, how do I know when I'm done? How do I know I've gone far enough? Well, it just kind of takes some practice and some intuition. But this lesson tells you exactly what you're doing. So example 1, secant beta times cosine beta. We need to get that to simplify to 1. I would start with rewriting secant as 1 over cosine and then multiply times cosine of beta. So of course this would be cosine over 1. So cosines, betas reduce, and you have 1 equals 1. You are finished. Okay, with number 2, we want this to equal negative tangent squared. So if you check out your Pythagorean identities, you'll find that tangent squared plus 1 is going to equal, so tangent squared plus 1 does equal secant squared, so you can check your Pythagorean identities. And then cosine squared minus 1 is going to equal negative sine squared x. Okay, so if you're not sure where I got that negative sine squared, if you go back to your Pythagorean identity, it's sine squared plus cosine squared equals 1. So cosine squared minus 1, so that would mean subtracting the 1 from both sides. So this would be sine squared x plus cosine squared x minus 1 equals 0. But then move your sine squared to the right side. Okay, so that cancels. So you get cosine squared x minus 1 equals negative sine squared x. So that's the substitution I made. I did the negative sine squared for that cosine squared x minus 1. Okay, so now, well, how does that help us? Well, remember, one of the tools you have to use is changing things to sines and cosines. So secant squared, let's rewrite that as 1 over cosine squared and see if that helps us out. So this would be 1 over cosine squared x times negative sine squared x, and that would be over 1. Okay, so if I multiply those together, I get negative sine squared x over cosine squared x. And remember, we're heading towards negative tangent squared. So tangent squared is sine squared over cosine squared. So you can simplify that, and you are good. Okay, example 3. So we're going to work on simplifying the left side and get that simplified to sine squared. Okay, first with the numerator, you have a secant squared theta minus 1. So that is another Pythagorean identity, and that's going to be equal to tangent squared. And then I have this over secant squared theta. Okay, well, I know that secant squared is 1 over cosine, and I can also rewrite tangent as sine squared over cosine squared. So I'm going to end up with a complex fraction. But in your complex fraction, if your denominators of your fraction are the same, those can be reduced. And then what I have left is sine squared theta. So that equals what I was going for. So I am finished with that one. Okay, number 4, tangent x plus cotangent x. And we're heading towards a secant x times cosecant x. Okay, so that might look a little strange, but if I rewrite tangent as sine x over cosine x, and then cotangent is cosine x over sine x. So my thought here is I'm going to add these two fractions together. But in order to do that, I need them to match their denominators. So this cosine is going to need a sine. And the sine over here is going to need a cosine. Okay, so now what I have is sine squared x over sine x cosine x plus cosine squared x over same denominator, sine x cosine x. Okay, they have the same denominators. I can write them as one fraction. And I think you're seeing where I'm going, because look at this, sine squared plus cosine squared. So I have sine x cosine x. So Pythagorean identity, that's 1. So 1 over sine x cosine x. Well, I can split that apart. So this is going to be 1 over sine x times 1 over cosine x. Well, 1 over sine x is cosecant, and 1 over cosine x is secant. So there is my secant x times cosecant x. So, okay, going on to the next one, example 5. So on this one, it looks like the right side is more complicated than the left side. So you can start on the right side and then manipulate to get it to equal the left. So it doesn't matter which side of the equation you started on. All 4 of these we started on the left and then worked it so that it matched the right side. Now, one thing I didn't tell you that I should have is you may not cross over that equal sign, okay? I can't subtract something from both sides. I can't multiply both sides by something. So whatever side you're working on, you just have to work on that side and get it to equal the other, okay? I can't transfer information from one side to the other. All right, on this one, I'm going to get common denominators. All right, so I have a 1 minus sine x as a denominator and then 1 plus sine x as a denominator. So I'm going to multiply by 1 minus sine x on this second fraction. And then on the first fraction, I'm going to need to multiply by 1 plus sine x. Okay, 1 plus sine x. And what I get is 1 plus sine x over 1 plus sine x times 1 minus sine x plus 1 minus sine x over 1 minus sine x and a 1 plus sine x. Okay, so you may think that this looks like a mess. It really is not. Okay, I now have the same denominator, so I can add my numerators. I have 1 plus sine x plus 1 minus sine x. So you can see what's going to happen here. Those signs will end up canceling each other out, and I get 1 plus 1 is 2 from my numerator. Okay, in the denominator, if you look at this denominator, you have a difference of square pattern. So if I were to FOIL that together, 1 plus sine x times 1 minus sine x, okay, and I distribute. So there's 1, a minus sine x, a plus sine x, and then my last is minus sine squared x. So those cancel. I get a 1 minus sine squared x. So 1 minus sine squared x. Okay, this is going to come from one of our Pythagorean identities. Remember, your sine squared plus cosine squared equals 1. Well, if I move the sine squared to the right side, then that is going to be equal to cosine squared. And cosine squared is the reciprocal for secant. So this is going to be 2 secant squared x equals 2 secant squared x. And I am finished. All right, method 3 is you can work both sides of the equation. So I can work on one side, and then if I just can't quite get it simplified to what I want, I can go over and work on the other side. Now, again, I can't cross over. I can't add things to both sides or subtract things from both sides, but I can work on both sides of the equation and try to get them to meet in the middle. Okay, so this one, I think I'm going to try working on the left side. I've got a tangent cubed theta and a secant squared theta. I might try going with sine cubed. So I'm going to change everything to sines and cosines. And then divided by 1 over cosine squared theta. Okay. So I got a complex fraction. So if I kind of rewrite this, it'd be times, okay, because this fraction divided by a fraction. So I'm going to multiply by the reciprocal. Okay, and now I can take out a cosine squared and a cosine squared there. Now there will still be a cosine. Okay, so now I have sine cubed theta over cosine theta. Okay, well, it might be that you're not sure where to go after that. So, I mean, I do see a couple things I could do and keep going, but maybe I'll work on the right side. Okay, so if I work on the right side, I have a tangent, and then I have this 1 minus cosine squared. Well, right off, this 1 minus cosine squared, that reminds me of the Pythagorean identity. So I can go tangent of theta times sine squared of theta. Okay, so now am I getting something here that I can use? Well, I can, because look at what tangent is. Tangent is sine over cosine. And if I'm multiplying that by sine squared, well, this is over 1. Guess what? I'm going to have sine cubed theta over cosine theta, and that matches. Okay, so I worked both sides of the equation. I got them to meet in the middle. So I have shown that identity to be true. Okay, so let's try to do one more example here. And, well, I think I'm going to work on maybe the right side. So secant, I could rewrite as 1 plus cosine. Tangent is sine over cosine. I have common denominator, so I can go 1 plus sine over cosine y. And then, figure out what I can do. Okay, well, I'm going to work on this left side. So what I'm going to do is I'm going to multiply this fraction by 1 plus sine y on top and bottom. Okay, now it is legal to do that because I am multiplying by 1 in the form of 1 plus sine y. So this becomes 1 plus sine y times cosine y over 1 plus sine y times 1 minus sine y. Okay, so over here on the left, okay, if I multiply that, distribute, I'm going to get 1 minus sine squared. And in the numerator, I have 1 plus sine y times cosine y. Okay, so how does that work with my left side? Okay, you can, what we could do now is we can distribute. Hang on.